I want to review the division algorithm that's commonly called the long division algorithm that we use in America, especially in a lot of late elementary classrooms and early middle school classrooms. A lot of students really get stuck on these steps, and so this is just a quick review of those steps. So first I'm going to take 7. I'm dividing 740 by 9. And what you might see that written as is 740 divided by 9. I have my dividend, which is the number I start with, my divisor, which is the number I'm dividing by, and then my quotient goes up top. So most teachers might have you skip this step, but I think it's important to at least look at it. 7 divided by 9 equals 0. It goes in 0 times. Now I could go ahead and show the work for that too. 0 times 9 is 0. I still have 7 left over, and then I bring down the 4. Again, since that's 0, I could just leave it out. Zeros on this side of the number don't affect my quotient at all. So now I'm looking at 74 divided by 9. 74 divided by 9, I can use some multiplication to figure that out. I know that 9 times 8 equals 72, and that's going to get me close. I hear a lot of students get stuck on that part because they realize that 8 times 9 doesn't equal exactly 72, and that's where they kind of get stuck. They really want those two to match. And in the long division algorithm, we don't need them to match. That's what those extra steps are for. And then I multiply my partial quotient times my divisor. 8 times 9 equals 72. The whole reason I do this is partially to check my math, but also to figure out how many parts do I still have left to divide. So 74 minus 72 is 2. And then again, I bring down this number. Of course, there's other ways to use the long division algorithm, and I may cover those in some future videos, or you can find some other ways to do it. If you don't like this way, there's a lot of ways to divide. It's important to find something that makes sense to you that you can do hopefully quickly. So now I'm taking 20 divided by 9. So 20 divided by 9. 2 times 9 equals 18, so I'm going to put my 2 up here. And I have 18. And I'm going to subtract 20 minus 18 is 2. Now this ends up being my remainder, because 2 divided by 9 is not actually part of my answer. Well, it's part of my quotient, but I can't fit 9 into 2. So what we do in late elementary school is R2, and R stands for a remainder. Now we could also express this quotient in a decimal or in a fraction. I'm going to cover that later in this video, but here you have a quick review of the steps. And I've got a list of those. We divide first, then we multiply. Once we put our quotient up here, we multiply the quotient times the divisor. We put that underneath our dividend and subtract. Then I start those steps over again. Divide, put the quotient up here, multiply, put the product down here, subtract, bring down, and then I start over. And I get 82 remainder of 2. The reason we may use an algorithm is it helps us organize our work. So that makes checking for mistakes a lot easier. And then that also requires a lot less thought. You really want to put your thought into the problem at hand, not computing the numbers. So the less thought you can put into computing the numbers, the better. And obviously some teachers will allow you to use calculators, so it makes those steps easier, and that way you can think about the problem. So here's one problem, and I think it's a simple problem. This is something we might use excuse me, in maybe 4th or 5th grade, some 5th grade classes, but maybe some 4th grade, and you might see it in middle school as well. But it's a single digit divisor, there's no decimals, it's a 3-digit dividend. So a fairly simple problem. So my son has 740 basketball cards and wants to put all his cards in a binder. Each plastic page holds 9 cards. How many pages would you buy? I left this part of the question a little bit more open-ended. How many pages would you buy? So we want a number of pages as the answer to our problem. The number of pages won't necessarily match our quotient. So again, I wrote these steps. We're going to divide first, then multiply, then subtract. We check our work, and then sometimes we have a remainder, and those steps happen every single time. So let's start with that blue color again. We're doing the exact same problem. 740 divided by 9. So I have 740 cards. 9 cards go in each page. So my quotient should tell me how many pages I'm going to need. So I'm going to skip that first step again, the 7 divided by 9, because I showed it in the other part. So I'm going to go straight to 74 divided by 9. My partial quotient is 8. So I divided. 74 divided by 9 is 8. Then I'm going to multiply. My partial quotient times 9 is 72. I'm going to subtract those two numbers. 74 minus 72 is 2. And the check is part of checking that. Did I do that right? If it's a larger number and you're not sure of your math facts, you might even write that out, 8 times 9, and make sure you got it right. I bring down, and that's really my remainder. My remainder is 20. But I didn't get to my full quotient yet because this is still blank. So I go back to the top, divide. 20 divided by 9 is 2. 2 times 9 is 18. 20 minus 18 is 2. And that is my remainder. I said earlier we could also express that as a decimal, or we could express it as a fraction. First, let's take our fraction answer. If I take 2 divided by 9 and wrote it out that way, I could write it as 2/9. So one quotient is an 82 remainder of 2. Another quotient is 82 and 2/9. So I take my divisor and I make it part of my quotient. Now I'm going to delete this stuff here. And I'm going to show you the decimal part. To do the decimals, we have to extend the problem a little bit. And I may not have room. I'm going to just do 1 decimal. So I add a decimal to the quotient and the dividend. And then I add another digit of 0, because 0 doesn't change the value of my dividend. So then I end up with 20 again. Well, 20 divided by 9 is 2. 2 times 9 is 18. I already see a pattern going here. If I subtract that, I'm going to get 2 again. I'm going to get another 0. That's going to be 20. That's going to be 2 repeating. It's just going to be 2, 2, 2 over and over again. So this quotient is, I'm going to write it over to the right so I have a little bit more room, 82 and 2/10 repeating. And that's the long division algorithm.